Welcome, dear friend. In this video, I'm going to take you through a walkthrough of checking account Solana program code walkthrough. So what that means is that we are going to check out a live vectored smart contract written in Solang Solidity on one of the official Solana program example repo, and I will walk you through the code step by step, how it works, what you can learn from it, and at the same time, at the end of the video, we'll deploy and try to confirm that this works. I'm telling you, this live walkthrough is so important because it gives you the opportunity to go through vectored live tested examples of smart contract code written in Solidity Solang on Solana, and by doing that you can incorporate a lot of this lesson in your own contract when you are developing them using Solang Solidity. So if you are new here, I am Solomon Foske, founder of dProgrammingUniversity, platform where I release free Web3 development courses, deep dive, and a lot more. And at times I do as well discuss non-developer, non-technical Web3 focused content as well. So if that interests you, head straight to the platform, dProgrammingUniversity.com, and start taking the courses and going through the in-depth guides to get you started and get you better as a Web3 developer. At the same time, subscribe, tap the notification bell so that you don't miss upcoming Ep2 videos like this. But before I get right into the details of today's code walkthrough, I have some disclaimer and disclosure to do. Please, you need to understand that doing guides, in-depth videos, courses like this free is not cheap or free. It takes time, research, and resources. So sometimes we take support in terms of grants, bounty in token, or whatever compensation form from some of these projects that we talk about, or through their affiliate. So please have that in mind. But at the same time, I try my best, or any of the deprogramming team, doing the content to ensure it's as helpful as possible. Now, that aside, the disclaimer is that please, any content released in dProgrammingUniversity, including this, should not be taken as and does not constitute as anything like investment advice or trading advice. It is just purely for educational purpose, not development advice, and not an advice to invest in any of the projects we discuss. So if you are taking part in any or all of this content, you agree that will not be liable for any losses you may incur thereafter. So if you are okay with that, then let's get in right into the video in details. Now back to the full focus of today's video, which this is another series. I've done a previous series about examining an Hello Solana, Hello World smart contract written in Solang Solidity. And for those of you that are new to Solang Solidity, Solang Ep2 to be able to compile Solidity smart contract and deploy it as like a native Rust or any other smart contract on Solana. So, and since it came out just about a few weeks ago, I've dedicated my time to do research, test a lot of things, and release a lot of content over and over to help in the journey of Ethereum's Solidity developer transitioning to Solidity Solana developer. So this is one of it, and we'll analyze what this is about step by step. I already have a written content which we'll be going through together, and you can go through. The link will be in the description for you to go. So we'll look at what is checking account about, why should you be going through walkthrough videos, what are the benefits, and then we try to set up the development environment for us to start testing these things together, while at the same time I will walk you through the Solidity Solang smart contract code. Now, if you go through on dProgrammingUniversity under the blog, or you search, then, or link in the description, you see this is like the episode 2. If you go through, like under the intro, it says, in this second walkthrough guide, I will be taking you through by hand to examine the checking account Solana program code base written in Solidity with Solang. So the essence of this checking account Solang Solidity smart contract walkthrough is actually to help Solidity developer understand some security features that can be implemented in their Solana program to ensure security and invariant in their Solang Solidity smart contract remain, to make it uncompromised. Now, for those of you, if you are new to Solidity, one of those things Solidity use to keep the smart contract secure is called invariant. That means a state. So by using things like require and things like that to check that invariant, you are able to know, okay, if anything is wrong, if to reverse the transaction or to complete the transaction. Now, one of it is this is a refer to the condition and properties that a Solana program, smart contract on Solana is a program written in Solang Solidity expected to hold true and head unchanged throughout the execution of the program. Any deviation from such is considered a security concern for the smart contract. So let's see an example. For example, you have a smart contract account executing a transaction to transfer from account A to account B. Now, account A, let's say account A, okay, let's say account A and this is account B. Account A has 5 souls. That's 5 Solana coin. And account B is expecting to get a transfer of 4 to this account B. Now, this account A, once it start executing the transfer, the chain of the transfer, sending the instruction and the transaction to the Solana blockchain, and the 4 is being transferred to this B, mathematically you expect that account A should now have a balance of 1 soul out of 5, because is already like transferring 4 to account B. But then that state of having it to be 1 soul is what is called invariant, and it must remain true till the last piece of code of that transfer instruction is completed. If for any reason, whatever reason, maybe the smart contract or whatever, has any issue and the invariant become false, let's assume something moved from, instead of being 1 soul balance from 5 after removing 4, is now having 2 or 3, yet it is transferring 4, then that's like 7 or 6. So that's something is wrong. What happened is that the transaction will be stopped and then unroll, because a lot of these blockchain transactions are atomic transactions. And when you say atomic transactions, means is either it completed totally or not at all. So even if it has 20 steps to execute, if it executes to 19 out of 20 and the remaining 20, the invariant is invalid, is false, it will unroll the first 19 as if they never happened before. So that's one of the beauty of things like this security check on blockchain like Solana as well. So that's the essence of what you want to learn and want to do this. So you want to see how this actually works in code, so that when you are writing your smart contract in Solidity, Solang Solidity, to be deployed on Solana blockchain, these are essential checks you need to put in place to ensure your smart contract is not compromised after being deployed as a Solana on-chain program. So I hope you get that, and I have an head up here that if you have gone through like the first episode or any other episode, then of my walkthrough video, you can just skip to like section 4 of step 3, because that usually is steps before that are just the same across the guide, because you need to set up environment and all those things. So you should already have that. So that's, we've discussed the benefit of this walkthrough code. It give you live experience, and these examples I'm walking through are what has been vetted by the Solana lab team, which is the platform behind the Solana blockchain itself. So at least to a level, we can still at least know that, okay, this could be reliable as much as possible, but always make sure you do your own check and research as well. So that's it. And if you get stuck, I already created this specific Solana channel in the dProgrammingUniversity Discord channel. So straight there, and you always get support for any of our Solana related content from the dProgrammingUniversity. So the prerequisite you need for this course walkthrough video is for you to have knowledge of Solidity. So if you don't, you can take my free course to get started on it. That's why I said you should skip all this if you have already set that up before. But if you don't, you need to have it, because if you don't understand Solidity, it may be difficult to even understand a lot of things like invariant or the code, how it was written and things like that. So this is not meant to teach you Solidity or Solang Solidity. This is meant to walk you through live examples for you to learn from and get better in your development. So then you need to know what Solang is, how it helps make it possible to use Solidity on Solana without actually Solana building an EVM compatible blockchain. Like Avalanche now has a C chain that is compatible with EVM and things like that. So Solana doesn't have to change from what it is with the help of Solang, a Solidity compiler. So check my ultimate guide for that. It helps you to get everything you need as a beginner into developing with Solidity on Solana. Well detailed, everything including videos and everything is there step by step for you. Now that being said, the next thing you need now is to set up Solana development environment for your Solang Solidity. So for us to test that code, to go through it together, you need to test it with me, and there are also exercises to get better as well. So to do that, you need to have the environment set up. So the video is already integrated for you. I think I will fix this. I don't know why it's not playing through, but if you go through this guide, it's there as well, but I will try to fix this after recording this video. So once you are done with that, then it's time for us to move on to the something. So you always have the video integrated after the recording. So the next thing is the checking account. So the first step you will need is for you to go to the I told you is from the Solana Lab official platform. So you go to this GitHub Solana developer /program-examples. Once you go here, you'll be able to see a lot of examples, which I'm taking one by one for us to get deeper. All these things help get deeper, so that whatever you've learned, you can see them actually being used. So we are dealing for now with the basics. So you go to the basics folder, and then we are discussing about this. I think I need to go back. So you go to the basic, but before you do that, for you to have it on your system, you need to clone this. So we do this, we copy and git clone the repo itself. So, and then we'll be discussing about checking accounts. I think we have discussed about this in the previous one. So we'll be discussing about some other ones in the future as well. So that's why subscribe, tap the notification bell, share the video to help others on board to Solang Solidity for Solana development. So we'll be discussing about this. Actually, I will be focusing on Solang. So let's take it step by step. So once you clone this in your terminal, just git clone and have this. Then once you have that, I won't do it because I already had it from previous one. You have this example folder, program examples. So you cd into it, and then we go under basic. Then we are focusing on this particular one. So you can open this. For example, I'm on Linux in terminal and then code and open. For example, let's do like this. If I do this, it opens it up in VS Code for me. You can see it opens it up in VS Code for me, but it usually used to be a bit confusing because there are a lot of examples to deal with there. So what I usually do, since each example is standalone, so I usually do is, let's minimize this. What I usually do is to go to the precise example to avoid confusion. I usually go straight from here, basic, then go to checking account, the folder itself that hold the example we are focusing on. So I come here and open in terminal. So it's actually open to the example itself. Then I can now open it in VS Code. With that, it will remove dealing with so much folders that could be confusing, especially as I'm doing the video and you're trying to follow which one I'm actually dealing with. So you can see it now. We only have the checking account that we are dealing with instead of the whole bunch of other ones we are not using here. Now the next step you want to do is we are focusing on Solang. So we have it in Anchor. Can go through the README. Say Solang program should perform checks on instruction to ensure security, and that require invariant are not being violated. So you see this now. So there are a lot of different checks, but these at least relate to account to ensure things are as expected. Now we are going to Solang because we are using Solidity. The other ones, these are like Rust and then native Rust and then Anchor. That's also Rust. So we are focusing on Solang Solidity. That's why we go to the Solang folder. Inside here we have some files and folder. Let me quickly introduce you to them in case this is your first walkthrough. We have this .anchor. You may not see it. It's because I've tried to run some things there. That's why you may be seeing this node modules as well, in case you don't see, but this just ignore for now. What you likely see is just the Solidity, then the test, and this git ignore, anchor, and package JSON. So usually this will occur later down the line, and it helps us to check log of our Solana smart contract. This is actually for node. Then the Solidity folder is actually the main focus of our walkthrough, which houses the Solidity code that will now be deploying on our Solana blockchain. Then we have this target as well will be auto-generated, so don't worry about it. The test, that is another essential part which help to run a test to ensure whatever we have here is just like a kind of a mini front end trying to interact with your smart contract to ensure that the functions and all those things you put in your smart contract are actually working as intended without actually putting up a whole full front end. So that's the testing, and you see is in our TS file, that's TypeScript, while this one is .so, which is the extension for Solidity. Let's take this, then we have the git ignore to ignore what you don't want to commit. Another important file here is the anchor file, which help specify how the anchor, by now that's why you should go through the requirement, the ultimate guide. You should know what an anchor is, a framework used to develop on Solana, but also integrated with Solang to make things super easy for the development. So this helps us to set up a lot of things, including the program ID, then a lot of other things like which Solana blockchain or cluster we deploying in. Is it local net, mainnet, divnet, or testnet? So I have a video that I've broken on that for you. You can go and watch it in the ultimate, I think it's also in the ultimate guide for you as well. So this Solang, you can go through the ultimate guide, is there for you. Now this, we are on the local net, so if you want to have access or test it with others, then you can change this to devnet as well. Then the script to run this test file that we have here and test our smart contract. So those are the major ones. Other ones are package.json, that is essential for the, you know, you are using TypeScript, so use yarn and all those things like that. Then I think those are the major things you will actually need. So let's start taking this one by one. First, let's check through the main one. Want to walk through the code, which is the checking account .so inside the Solidity. So these are actual smart contracts that we want to use to test the invariant and see if they are actually working as expected or not. So before we move on to start having a walkthrough of this smart contract, I want us to be doing something you need to do according to the README. Once you have any of these example, the first thing you want to do before you start running some command to test it, you run your terminal and do yarn or yarn install. So to install all the needed dependency by the anchor, yarn, and all those TypeScript and all those things. So you put this, I want that to be running. You see is done already, and you see that was how some of these things were auto generated. Then the next thing, as for you, depending on network, that may be running. That's why I did it, so you can just do it and allow it to be running while we continue checking. So let me close it since we have it done already. Let's quickly go through. We have the import. Can I minimize this? Yeah. So we have the import already, Solana. Then we have this program ID. If you have gone through series of Solana, either in Rust or whatever, that's how Solana blockchain is structured to handle the Solana programs. It requires about two major things across, either you are using Rust and other things. Usually the program ID and then the payer, because Solana deals with rent for the smart contract state data account. If you want to learn more, that's why the ultimate guide is there for you. I've broken down everything so that when you are following this, you can comprehend what I'm saying. So we have that already stated. Then this the payer, you can see it as well. And as usual, your Solidity smart contract is always boxed inside the keyword contract. So we are dealing with the check, and this is the name of the contract. So we are dealing with that. Then you will see we have the payer, like I told you before, which you need to pay for the rent when the data account is created, non-executable account is created to hold the state of our smart contract and things like that. Then we have the constructor, which is usually a code that runs once a smart contract is deployed, usually to initiate. If you want your smart contract to be in some specific state right from the point of initiating it, but not something that you want to be running over and over like that, you put the code inside the constructor. But here now is empty, so we have nothing actually to deal with there. So let's go right straight here. Let me quickly see. Here we have basically 4 functions. One, the check account function, then program owner check, then we have the third one, not initialize check function, and the last 4th one is signer check. In the previous walkthrough video of the Hello Solana or Hello World Solana program, I told you then we didn't have any function outside the constructor because it was just a basic hello. I told you then that if you want to run actual Solana program, you have a lot of function that does a lot of things, then you have it outside the constructor. So that's perfect example we are now seeing here. That's why continuing to follow this series of example walkthrough will help get you up to speed and better with best practices with Solang Solidity on Solana development. Subscribe, tap notification bell, and get confused out, need question concerning any of our Solana related content on the programming Ep2 to Solana dedicated channel in the dProgrammingUniversity server. Now let's take this one by one, and in case any background noise is coming up, please I'm sorry for that. Yeah, let's look at the first function that we have here, which actually happen to be the main function. If we look, just glance through, you can see is the main function here for us. Now the function check account, you can see it takes in 2 arguments or 2 parameters and is public and view. Take it one by one. The parameters are of type address, so which means whatever they are trying to take in is an address of an account. Then we have the public and the view. Whenever you see in Solidity that you have public, which means this particular function is open and could be called from almost like anywhere, any smart contract, anything could try to interact with it. But this view limits what it can do in terms of impact modifier. Like this can only view the state of the smart contract. It's not meant to change the state, so we call it setter function. Getter function, not a setter. Setter interact, change the state, but this is just a getter, just to get details of what has actually happened to that smart contract state from the blockchain. It's actually not changing anything. So we have this, the print, which usually is to print out log information or whatever is happening to based on where you use it. So it's a number of accounts provided. Is like when we wanted to start this, it tried to give us like how many accounts, so that as we go on we'll know what is actually going on. Don't worry, we'll run this together, but at least it's good we have a workshop of how this code is. Then the next one you will see is a for loop. So this, as a for loop, it's set up some conditions that need to be met, and as long as that condition is met, it continue to execute whatever code is inside there. If not, it just get out of the loop, or else it run into infinity. So now this is trying to check for us this tx.account. If you go into the guide, you will see it there. So that's why you can also read through and watch the video together. This actually hold the account, is like is dead, holding the account involved in that particular transaction for us. So with that, we can now use it to check and do a lot of invariant check and things like that. So we need to just ensure that this is equivalent to account to change. So if it is equivalent to whichever address we put in here, account address we put in here, then you should print it out that okay, fund account to change. Then once that happens, you should call this function program owner check and pass that particular account to it, which is what this receive. We'll see that later, but that is it here. Maybe we just go through it since they are interwoven. So you can see it here now that it just takes in this that was passed in here, and then we'll come back to explain all this internal and pure later. So but for now, you just know that if this particular if statement is true, then this gets printed and this gets executed. Pass this to execute, call this function, pass it whatever it needs, and then it gets executed. Then it's check if this also is true, the condition if statement is true, then print account fund to create, fund account to create. Then not initialized check, that's another function here. You see it, that's the third function. It calls that and pass the same value that was passed here, pass it in. Then also call signer check, so pass the same thing and pass it down here. So which means that's why I said this is the actual main function, because it's check with whatever we pass here as account to check. If this pass the check, then straight it pass this and execute. Now I've minimized it and execute the program owner check. And at the same time, if this also account to create is fund, you can see it fund the account to create, then it should as well execute both of these. So from this you can see that account to change, then account to create. So we now as well take this one by one. Other ones wasn't actually implemented. So the function for program owner check, you remember, that's if we see this account, we find it in parts of the transaction account, list of accounts that's involved in that transaction. That's when we want to check that okay, does this program owner check, now is this program the actual owner? Like in Solidity, you have the executable account and the non-executable account. Your smart contract on like Ethereum is just one. The data, the state, everything, and the smart contract code, bytecode is there. So you may get confused. That's why you should go through the ultimate guide. Everything is well detailed there. Then, but in Solidity is two. There's one that purely just hold executable code, the bytecode, and there's one that hold purely just the state, and they work together. But to make things secure, it is always, that's why part of the reason why it's always a kind of requirement to check, to pass in the program ID. So this always check before it allow changes. Somebody can send token so or whatever is accepting can interact with it with a kind of a getter function. But anything that setter function that will change the state of that smart contract, this will first check that that smart contract trying to change the state is actually its owner. You understand what I'm saying? So it's the one, or let's say a kind of a parent and a child. So the child will check, is it actually my parent? If not, then it's a stranger. I can't trust whatever is sending. You understand? So that's what this is trying to check for us, that is that account program actually the program owner. If not, then you should not execute it. So that's what you are seeing here. It tried to check for us, but you will notice that this has internal and pure. These are modifiers in Solidity. So this internal means this particular function can only be called within this smart contract. That means any function, any call that this thing will honor, like it was called here and this was passed into it, the parameter is required was passed into it. Anything that we call it like this must actually be a function inside this checking account smart contract or any other smart contract, as long as it must be within this block of code. If it's not here, it won't be executed. It won't even allow it to fail. The only condition is also if this whole contract was also inherited by that smart contract. So it's like it's already part of it. But for an outsider or just something to just call it, it won't work. So it's a good security measure. Plus this pure ensures that this whatever code that is run inside here does not interfere or change the state of the smart contract itself. So this is like security. That's why you see that it's part of checking to ensure that no matter what happens with the smart contract, whatever code inside this pure does not actually influence the state of that smart contract account. So those are important. That's why it's good to watch and go through and follow walkthrough videos like this, because it helps you to see real life implementation, and good for us that these are even implemented by official repo of the program examples. So it gives you what is actually being tested and proven by the Solana blockchain team themselves. So that's why you should subscribe, tap the notification bell, and head straight to the Discord if you need support or ask as well question in the comments. If you find this helpful, let me know, and any other walkthrough you want us to do, let me know as well. The same in the next function, you see carry the same thing, so which means all these functions we can call them Ep2 function, because they are not actually a standalone function that just work on their own. They are actually there to help the main function. That's why we call them the Ep2. So the whole three are actually helping this particular check account function. So this has a require statement which check that this account with this program ID is it actually account to change does not have the correct program ID. You understand? So the owner of this account should be this program. So if you go through, I break down everything for you step by step as well. You can see. So this check account does about 5 things. Take into argument, it has a for loop which helps to loop through all the account address involved in transaction. They are stored in the transaction account I've showed you. If the account to change address is found, it triggers the execution of program owner check function which we are checking. If the account to create address is found, it triggers the non-initialized check function and signer check function. So you can see the breakdown as well in the guide. So let's go back to the actual code. That's what this check, this print out program owner check. Then the next one is not initialized check, which is triggered to create account. So it's like you want to create a new account on for this program. Now you need to confirm if this account was not previously initialized, because that could cause you, if you try to reinitialize existing account, you may wipe off the state and things like that. So you want to ensure you don't cause serious damage and things like that. So that's why we need to check this invariant as well, to be sure that okay, this thing is, now you see that it's checking require account dot lamport is 0. So lamport is the smallest divisible version, what do we call it, of Solana as a whole. So it's like you have US dollar and you have your cents, you understand? So I think yes, USD use cent, I think it's pounds that use penny. So you have your 1 USD, then that's about 100 cents makes a USD. So that I think is about 9 denomination of that, 0.0000 and things like that. So if that means, for example, if I want to check in this account that this account, if it was initialized, because it has to pay for rent, it will have certain amount of like so inside of it. So I may not be sure if it has 1 or 2 or 3 or 5. So the best least way to confirm it is to check. So if this thing should have about maybe 0.50 cent or 100, let's say 1 USD or 2 USD could have 10 USD, I can just want to know, I can just say, okay, does this thing have a 0 cents? If it has, then it has not been initialized. If it has been initialized, it must have at least 1 cent. You understand what I'm saying here? So that's what we are checking here to confirm if it has at least, the program expected the account to create to not yet be initialized. So if it is not equivalent to 0, if it is at least 1 lamport, or let's say 1 cent, then it means this has been initialized. So you have to be careful. You may terminate that process so you don't override the existing account and cause loss of data stored there or something like that. So that's why the check is there. Then the last function is the signer check, which is also triggered here. What this does is this account should be a signer on the transaction. So it need to confirm that this account does actually have the capability needed to create an account for this program. You understand, things like that. So all these are like essential things that are real life checks you will likely want to integrate into your full something. So the walkthrough are not about giving you full code, Solang Solidity smart contract code to deploy on directly on Solana blockchain, but instead they help you to understand tested proven best practices. So as you build your whole smart contract together, you can know what should be and what should not be. So, and I'm also trying to test out and working behind the scene on some live full packed full stack dApp that we integrate some of these examples and use it to be a full dApp. So if you want to see that, let me know in the comment, and that's why you should subscribe, tap that notification bell to not miss it, and join the Discord as well. So, and if you find this helpful, please share the video, follow on Twitter as well, and share another social media, and share this content to your social media. It helps as well. Now that's the last part. Like I told you, signer check it if it is a signer. You understand? So if it is not, account required to be a signer. So like I told you, that's a red flag. That, you know, it's like you have a bank account. Anybody that knows that bank account can send in money. You will hardly have issue with it, except if the account is red flag or something. But when somebody want to pull it out, even the person that send you that money, let's say they mistakenly, they want to send it to another person, they mistakenly send it to your own, maybe missing a code and didn't verify the name before they do. That's what all this invariant does. Then they send to you. They cannot come in and say, no, it's my money, I mistakenly. It's no more their money. Before they need to prove to you and the bank and things like that, you understand, before you can send it back to them. If you are sending it back to them, like, okay. But if not, they cannot just go in. Because they could send in money freely doesn't mean they can take in money out freely. So that's what is being confirmed here, that because you can interact with it, it needs to check, because it wants to create a very important something, which is like creating, you understand. So it need to check very well to be sure if it actually is signer or just a stranger, and then reject the call. So that's basically what this smart contract is about, and how I check those invariants, and that's the major thing. The other one is just the tests, which like just have a run through. You are importing essential Solana Web3.js and all those things you need. All this give you access to, you know, sign account, to connect with based on the cluster you are, localnet, divnet, mainnet, and all those things like that. So, and the key pair, everything you want to set it up. If you are watching being new, don't worry, don't be confused. Always consider beginner with content in the dProgrammingUniversity. So make sure you go through the ultimate guide that took you step by step to create account, all this KPI and all those things. So here now we are generating all those things, connecting to the wallet, and then begin to initialize. So this initialize is when we begin to test this particular functions that we said here, to execute and see how they work. So to see if it's actually working or not, you can see them. Await program method check account. You see we are calling this particular check account, which is this, and you see, and this actually call the other three as well. You can see them. Then remain account to change pub key is writable true, is signer false. You see things like that. So this help you to like pass in the needed account to change and account to create for the test to be done. So you don't need to actually do this manually. That's the beauty of this test. So we'll now move to the aspect to do what? To run this together. Let's go back to the terminal. You see checking account, and we are under the Solidity. So make sure in your terminal as well. Oh, I think that was what they initially checking account. You ought to CD into Solang. Cool. So make sure you are inside there. This Solang Solidity. Yeah. You see we have this 4 folder or something. No, like 3 Anchor Native and Solang. You may have seen more in future, maybe see us for Python something. Now, the first thing we need is we need to build this smart contract, deploy it, then run that test file. So those are 3 things. There are different commands to use, but thanks to Anchor as one that does the whole 3, which is just Anchor test. Now let's try that. You can see it is building and then trying to run the test script. If this shows error for you, it didn't run, then you should know that you first need to do, remember, yarn install. I ought to do it inside the Solang, not the main folder. So you do yarn install. When you do yarn install, for example, if you have done it before, it will tell you that it's done. You can see it. If it wasn't done, this wouldn't be successful. It would have brought out error. So you can see that we successfully did this initialized, create an account owned by our program, your transaction signature, then check account. So the 3 test was what successfully passed. As you can see, it all executed in 24 seconds. So that's a sneak peek of how fast Solana is actually on the main net. So that's it. You can see it now, 3 passing, and we have everything successfully on. If you are stuck, remember we got you covered. You can go in the Discord, is link in the description, dProgrammingUniversity, and you'll be able to see dedicated channel for Solana where I'll be there to help for any of our content on the dProgrammingUniversity that relates to Solana. So if you have any question there, you can ask. Let me see. You see it now that it's on, and then some of these printout that we have, we can as well see them at work by going to this generated I told you before. No, sorry, that's why when you have too much, it's mixing. Make sure you are under Solang, not this anchor. Under the Solang, then you have the dot anchor, then you click, you have the program logs, click on it, you see the smart contract ID. Then if you read through, let's try and minimize this. Can you see it now? That you can see that it says that number of accounts provided 3. You do remember in our something here we indicated that it should tell us, you see, number of accounts provided. Do you see it now? Provided. Let me do something here. Provided. Yeah. You understand? So that we know that it's actually the one. So every of these print get output inside this log. So let me just test this, sorry, and see live for you. Let's open here. You can see every other one account font to change. So but at least this number of accounts provided, you can see it. Let's rerun it, anchor test, and just notice this account provided. You will see it. Do you see everything clear up? And we have our year added based on what we have added here. So that's your exercise to go through this, test it, make sure you go through, execute it, make it run. If you get stuck, ask for help in the Discord, the dProgrammingUniversity and Solana dedicated channel in the dProgrammingUniversity, your Discord server. So, and once you come here, just like what I did, try to just play around. The essence of this is just to make sure you actually follow and practice, because watching this walkthrough is not enough without actually testing the code, running it, and start implementing it. So just try to change provided by dProgrammingUniversity by your name. Yeah, so usually we prefer your Discord name, yeah, so that it will actually be, I'll be able to verify that it's just an exercise, you know, to be sure you are doing things. And like this now, if I try to run this, so just show a screenshot of this being run successfully, just the way I did it. Screenshot them as 1 or 2 differently. Let me see it, and you can see it by DPU, by your Discord name should be here. So I'll verify it with your Discord name and be sure that it's actually there. And I need to see this as well, that it actually on, and not that you try to game me here. So that's it here, and I believe we have really gone a long way and learned a lot. Let me know in the comment, in the Discord, share on your social media, like, and let me know which one example you like me to work on next, and I'll be glad to work on them together with you. And also join the Discord and look forward for more full stack dApp for Solidity, Solang Solidity on Solana in future. But for now, I'm still testing and working on some of them as well. And if you have any, you can chip in the Discord for me to check out as well and could review it. So that's it. Please like, subscribe, tap the notification bell, and always I remain Solomon Foske. Always keep the programming spirit and alive as your assurance to succeed in the long term as a developer. You don't want to give up. You keep grinding till you succeed as a developer. And please always do good to humanity and nature with your programming and coding skill when you eventually master things, so that we can make the world a better place for us all. That's it. See you in the next video, and peace and bye.